This problem here is 2016 AMC 12B problem 16. In how many ways can 345 be written as the sum of an increasing sequence of two or more consecutive positive integers? There are A, B, C, D, E, 5 options here. So 345, so let's just look at this number. So how do we actually split this up into two or more consecutive integers that are increasing? Well, one thing you can do here is just brute force for a while. So let's say we want two numbers. I think that's doable, right? That's doable for anything. You want two numbers that are positive and increasing. That sum to 3, 4, 5. Well, just just try and guess and see what 345 divided by 2 might be. Now, if you actually calculate this on paper, it would be 172.5. So now I take the two closest numbers to this, which are 172 and 173. They should sum to 345. So that's one possibility, actually. And, okay, so that's one possibility. So what about 345 divided by 3? Maybe we want three numbers in our increasing sequence. 345 divided by 3 is 115. So this gives us a sequence 114 plus 115 plus 116, which is 345 again. Now, obviously, we realize that we don't have that much time here to brute force this out. I mean, you can if you have a bunch of questions left and you don't know how to do stuff in the AMC. But, I mean, so for the better way to do this is to use the SMART method, right? So how do we do this then? So, firstly, let's just think about, so let's just call this n. So 2 and 3 are both n's. So n is the number of numbers inside our increasing sequence. So what values are possible for n? So we know that 2 and 3 are possible. And n has to be larger than 2 because it says 2 or more. Wait, so this says n has to be larger than 2. Okay, so what else? Well, so if you actually try 4, 4 doesn't work. And if you try 5, yes, 5 works. So what's the key here though? The key here is that n has to be either a divisor of 345 or 2 times the divisor of 345. Why is this? Because firstly, if n is a divisor of 345, 345 divided by n is an integer. If this is an integer, so obviously you can expand the sequence from this integer over here. For example, 115. This is the average of your sequence, and you want 3 terms in your sequence. Well, that's simple. Just expand it. Just go like, I want 3 terms in the sequence, and this is 1 term. So I want 2 more terms. 1 term should be on the left-hand side. It should be smaller than this average. 1 term should be larger than this average. And here we go. We have our sequence. So that's that. And what happens when n is 2 times the divisor of 345? In that case, 345 divided by n will give you a 0.5. For example here, 0.5. Because 2 is 2 times 1, and 1 is the divisor of 345. So this gives you a 0.5, but no worries, because so we know that 345 has no even divisor. So if you divide by 2 or any multiple of 2, you'll obviously get a 0.5 over here. So for 0.5, you can just expand onwards. You can say, so what's the 2 closest numbers that are close to 172.5? Well, there you go. And then, yeah, so that's your sequence. And if you want to expand even further, then example is 345 divided by 6, then you take the 0.5 and you expand it into 6 numbers. 3 that are smaller than the average, 3 that are larger than the average. So we want the divisor of 345 and 2 times those. So what are the divisors of 345 firstly? So divisors of 345, this is just them out. Simple, right? So 1, 3, 5, 1, 3, 5, 9, let's see, 9, well, 15 works. Yeah, 15. And then, so 15, 345 divided by 15 is 23. So 23 works. And, so 23 works, and I don't think any number in between this works. So 345 divided by 9 is, 3 times 9 is 27. 75 divided by 9, so actually 9 doesn't work. So 9 doesn't work as a divisor, so 9 is not a divisor. My bad. And 345 divided by 5 is 69. And then this divided by 3 is 115. This divided by 1 is 345. So what about 2 times these divisors? This is 2, 6, 10, 30, 46, 138, and then 230, and then 690. So you have all these possible values, but as you can see, the largest answer here is 7. There are a maximum of 7 ways where 345 can be written as some increasing sequence of two or more consecutive positive integers. Why is that? Well, let's just try out each of these. So casework. So 1 doesn't work because we want 2 or more consecutive integers in our sequence, so 1 doesn't work. What about 2? 2 works as above. So n equals 2 works. What about the second case? N equals 3 works. Right? And then what about the third case? Which is when n equals 5. When n equals 5, yes, it works because 345 divided by 5 is an integer. And it's the integer 69. So you can just take 2 numbers that are smaller than 69, which are 67 and 68, and 2 numbers that are larger than 69, which are 70 and 71. And you add those 5 numbers together, and you get 345. So n equals 5 works. What about when n equals 6? When n equals 6, divide 345 by 6, you get, if you divide that by 6, you get 57.5. 57.5. Well, you can take 3 numbers that are smaller than that and 3 numbers that are larger than that, as long as they're consecutive. Then, so that also works. So what about case 5 then? When n is equal to 10. When n equals 10, you get 34.5. 34.5. You can take 5 integers that are less than 34.5 and 5 integers that are larger than 34.5. As long as they're consecutive, they are fine. And they also have to be positive. So what about when n equals 15? When n equals 15. When n equals 15, 345 divided by 15 is 23. So that's an integer. But you can just take, so that 23 is one of the numbers, it's the average. So you can take 7 numbers that are less than 23 and 7 numbers that are larger than 23. So that we have a 15 number consecutive sequence. What about case 7? When n is 23. When n is equal to 23, there's a problem over here. So obviously 345 over 23 is 15. That works, right? So now all you have to do is take, so 15 is the average. Now all you have to do is take 11 numbers that are less than 15 and 11 numbers that are larger than 15. So actually no, there's no problem with this. 15 also, so n equals 23 also works. But problem comes in case 8. When you take n equals 30, when n equals 30, 345 divided by 30 is, well, let's see, 345 divided by 30 is around 12.5, around that. Now, if you take 15 numbers that are less than 12.5, then, so this is 12.5, right? So this is 12.5, and if you take 15 numbers that are less than that, you have 12, 11, etc. But then you get to 0, and this 0 to 12 is only 13 numbers, and you need -1 and -2. However, the problem here is that it says you need more consecutive positive integers. You need positive integers, not just integers. So -2, -1, and 0 can't be used. So, but if you don't use them, you can't produce a 30-number consecutive sequence that has a sum of 345s. So this doesn't work. So case 8 already fails. What about other cases, like even large numbers like 46 and etc.? Well, 345 divided by any n that is larger than this will obviously result in an even smaller value. So there will be even more negative numbers than 0 needed. So that they all won't work. So there are a total of 7 cases and the answer is E. So the key here is to realize that the pattern is we need n to be a divisor or 2 times the divisor of 345. Why is that? Because if it's a divisor of 345, all you have to do is just expand based on the average. If it's not a divisor of 345, it's 2 times the divisor of that, then you get a number that ends in 0.5. If you get a number that ends in 0.5, you can also expand on that 0.5 number. Other numbers don't work because you can try them on your own. So thanks for watching. Bye!